to the lowest. This is the requirement. Think like we do have 4 files from section A, B, C, D, but we need to give the ranking to the complete class. Okay, yeah, I'll share screen. So for that, I'm making the mockup data or dummy data on my system. So I'm creating a folder over here saying like student folder. This is section A data. I'm creating 4 files. I'm renaming the file names. These things will be provided in the requirement sheet in general. Since we do not have a specific requirement, I am creating the dummy data. Section C.txt and section D.txt. Okay. Now I am adding the data. Roll number, name, subject 1, subject 2, subject 3, subject 4, subject 5, and only 5 subject. That's it. 101. Fine. Now I'm copying the same line and replicating. Later I'll change the data. Zero two, 103, 104. Okay, I'm done with section A data. I'm also adding a column like section over here. Okay, now I'm saving this file and I'm copying the same data to section B. Then I'll change the data over there. I'm done with section B data. So we are done with making the sample data. Now what we need to do is we need to first combine all the files. So that thing we can able to perform with the help of funnel stage. Funnel stage is going to join the data from section A, B, C, and D. Later, we thought of adding the marks and calculating their percentages, right? After percentages, we are thinking to give a ranking for each of the score against each of the student. So let's open the data stage designer, and this is how we need to do the job. First, we are going to read the files like sequential stage 1, sequential stage 2, sequential stage 3, and 4. From each of the sequential file, we can read the data, and then we'll join all these links to a funnel stage, which is going to combine all the data. Then we will keep a transformer, which is going to use to calculate sum and percentage. Then we'll see how we can able to give a ranking. Okay. And then finally saving the data to a target. This is all what we need to implement now. So let's do it one by one. I'm opening a new parallel job. As I told, we need to have 4 sequential files. 1, 2, 3, and 4. Then after we need to link these 4 sequential files to a funnel stage for joining the data. So funnel, and I'm adding all these links to funnel stage. Then to calculate the sums and percentages, I'm using transformer stage. And finally, let me add a target file. Now I'm renaming the jobs. This is my section A data. This is section B data. This is section C. And this is section D. Okay. Now I'm renaming the links as well. Link from section A. So we need to give the link names in such a way that even though we get some sort of error, we can able to figure out from which link we are getting the error. That's why we need to take care while assigning the link names. Link from section D. And this is my class funnel. And then this is linked to transformer. And this is my transformer. And this is linked to target. This is my final class data. Class marks. Okay. I'm saving this job. Now I'm doing the configuration. So where the file is resided on desktop. So let's go back to desktop and copy the file name. So this is the path. Section A.txt. First line is column name true. And then columns. Format final delimiter and actual delimiter is pipe symbol. No quotations are there. Then in the columns, roll number, name, section, subject 1, subject 2, subject 3, subject 4, and subject 5. Okay. Roll number is an integer, name character, section character. All these are integers only. Done. So plugin is done. I'm saving this metadata because we need to add similar kind of metadata for other sequential files as well. I'm saving it as section data in March folder. Okay. So we can import the metadata there. First, let me view the data if the plugin happened as expected or not. We can also copy this stage and paste again so that all the things will retain the same. So whatever we did configure, the details will remain same only if we copy the link. So all these details what we are giving in the properties or in the format or in columns are going to save in my link, not in my stage. If I remove the link, then all this is going to vanish. So I can able to read the data. Close. So if I would, I can configure these things manually again. Still there is an option. So if I click this stage, click on Control C, which is nothing but copy activity, and Control V, which is a paste activity. Okay. So if I open this one, the same configuration will retain. We just need to rename here as section B. That's it. But we should not remove this link. If the link is removed, then all the details will vanish. Let me show you that as well. So here I can see the metadata and format as well, right? So if I do remove this link, delete, yes, then I don't see anything over here. So all the data is going to be saved in my link, not in the stage. Whenever we need to copy the things as is, then what we need to do is we need to copy the stage. Click on Control C to copy it. Click on Control V to paste it. Then you can rename these things as section B. And since section B is already available, it is not allowing. Let me add section SEB. So here we can change the things. Instead of section B a.txt, we can keep it as section B.txt. And then we can also change the link name. That is one way to do it. But here I'm importing the things again because I already added the skeleton part, right? So the file name, I'm copying this path. Section B.txt. First line is column names. Delimiter is pipe symbol. Quotation as none. So columns I'm loading. We have saved in March folder with the name SCC data, which is section data. So I opened this one. I want all the columns. So all the columns are there in my right section. The columns which are populating to my right section are going to be added in the console. So all the details been added. Similarly, I'm doing the same activity for section C as well. File name is section C.txt. First line is column name, which is true. Format delimiter is pipe symbol. Quotation is none. And I'm loading the columns. Doing the same activity for section D as well. First line column names is true. Again, I'm loading the columns because all do have same metadata. Done with all the 4 files. Now let's go to the second section, which is funneling activity. I want all the data to be funneled without any order. So I'm selecting continuous funnel. We already discussed about sequence funnel and sort funnel as well. Here, we don't need these two things, sequence or sort funnel. So I'm selecting continuous funnel. But here I want all the columns, roll number, name, section, and subjects as well. So I'm clicking on the header, which is columns, dragging and dropping. So all the things are mapped to the output column, output link. So now all the columns are available to my transformer input link. Okay. So I'm opening my transformer. Here what I need to do is, so I'm copying all the columns to my output. After all these columns, I want some extra columns, which is total marks and rank. For ranking, first we need to do sorting, right? So unless until I do the sorting activity, I could not able to give the ranking. But I also need percentage. So I'm keeping percentage as well. We can calculate total marks and percentage over here. Total marks is an integer. Percentage can be a decimal. So I'm selecting here decimal. Okay. So how total marks is calculated? Sum of all these subjects, right? So how to calculate sum? Here, click on these three dots and go to the function. Check if there is any sum function available in these things. So that might be available in mathematical functions. Go there and check if there is any function like sum. In mathematical section, there is no sum function. So I'm searching in numbers. That is also not available over here. Let's randomly check if that is available somewhere. Utility. Here also it's not there. Okay. Nowhere it is there. To do the sum, let's give the derivation something like this. Input column subject 1 plus input column subject 2 plus input column subject 3 plus 4 plus 5, subject 4 plus subject 5. This is how we can able to calculate the sum. But to calculate the percentage, again, I need to do the similar activity, right? So if we would like to perform the same thing twice, it is best to do the activity in stage variable section. Otherwise, what happens is the same summing action is going to perform 2 times. One is for calculating the total marks, other one is for calculating the percentage. That will consume more time. So to have an optimal operation, here what I'm doing is I'm appending a new stage variable, and here I'm adding the total marks. I just cut that derivation and I pasted over here using Control X and Control V. So my stage variable is, let me rename this one. Right click over here, click on stage variable properties. There you can change the name. This is nothing but total marks. So which is an integer. So now just click over here, drag and drop to the derivation. That means this calculation value is going to be added to your total marks. So how we can able to calculate the percentage now? Again, I want total marks divided by, which is nothing but this symbol, divided by 5 for into asterisk symbol and 100. This is going to calculate my percentage. So now I map percentage and I also map total marks using stage variables. When there is need of implementing same activity in column derivations, we can make use of these stage variables. You might be asked a question like, what is the order of execution in transformer? Or what are all the components that are available in transformer? Through transformer, we can define stage variables, we can implement loop conditions, and we can also give derivations to the output columns. The order of execution starts from stage variables. First, stage variables will be executed, then loop conditions will be executed, and after that, these derivations will be executed. And there is also constraint option. This constraint we have already seen. This is nothing but adding a filter. When we do have multiple output links, on which basis you would like to send the data to each of the output link can be determined using this constraint. Okay, so at last constraint will be executed. So we need to answer first stage variables, followed by loop conditions, followed by column derivations, and finally constraints will be implemented one after the other while executing a transformer stage. Hope you get the point. So this is how we can able to calculate total marks and percentage. I'm clicking OK. Now we need to add the ranking, right? So for that, again, I need to keep a sort activity. We can also perform here itself. But now if I use all those functions, it will be little confusing. Let's calculate till here and I'll show you how to add the ranking as well. I'm saving the final. I'm adding the target file to the same student's path. TGT student marks .txt. Delimiter pipe symbol, no quotations. That's all. So extra 2 columns been added over here, integer and decimal data types. And one more thing is, now we can drag one more link from transformer where I can add the sort stage to sort the data. Okay. Now I am adding one more transformer for assigning the rank. And finally, I can save the target to a file. So if we do all these things, it will be little confusing. But this section of code from transformer to sort, transformer and file, I'll explain this tomorrow, this section. So I'm deleting this for now. Let's try to execute till this point. Okay. Everything been added till here. So I'm compiling the job. There is an error at transformer. So for decimal data type, we need to give the precision. Precision means how many values need to be added after a decimal point. That can be defined here. So the length is something like 5, where the scale is 2. That means, let me show you. Say suppose the percentage is 99.5. 99.50. Okay. So the length of this decimal data is 5 because 9 is 1, second 9 is 2, dot is 3, 5 is 4 and 0 is 5. So total length is 5. Precision is 2. Precision means the number of digits after decimal point. So the length of this particular data is given as 5, 2. If I say something like 7, 3, that means total length can be up to 7 and only 3 decimal points or after decimal 3 values are allowable if it is 7, 3. This 7 includes this 3 length also. Even here also the 2 includes in 5 as well. So 2 values allowed before decimal, 1 is for decimal, 2 values allowed after decimal. Okay. So for us 5, 2 length will be sufficient. So I'm keeping the same 5, 2. Now I'm recompiling. Now job successfully compiled. Let's execute this one.
ఎందుకమ్మా
16 rows came till transformer, but after that 0 rows went to the final target file. That means there is some issue from transformer to file. So let's see the log. Control L is the shortcut to see the log on designer client. So data been rejected over here saying that the source decimal have even precision but non-zero in the leading nibble is too large. Let's add some more length. and see how it goes. Also here I am adding braces so that it will be easy for the compiler to execute it. Job successfully compiled. Let's re-execute. Now all the 16 rows moved to the target. Let's view the data here and then from the file as well. So here, okay, into 100 is not needed because all the subjects are for 100 only. That's the reason our percentage not calculated for 100 but more than that. Let me change the calculation over there. So after creating the job and executing, we need to test it thoroughly that it should able to satisfy the requirement. Otherwise, we need to check for the errors and fix each of them. Now it came correct, but I don't want all the zeros before my data. So we can also remove these zeros in the function as well. That we can able to perform through the string functions that are available here in the transformer itself. But before going to that, let's also see if we can able to add the ranking. Here I'm calculating hash function. I mean hash partitioning or same partition. Okay. We can perform the sorting in input tab as well, but we need to add the sorting activity on total marks, right? Total marks is not available in this input, but that is available in the output link of my transformer. So what I'm doing is I'm dragging one more link and adding a transformer over here. This is for giving the rank to each of the student. So here I'm trying to add, I'm keeping a peak stage. Peak is available in development or debug. This is peak stage. The main purpose of peak stage is to see how the data is coming. Once this functionality is working, then we can replace this peak with the actual target stage. So what I am trying to do over here is I am capturing all the data which is available from my previous output link. So I want the same derivations. That's why I'm dragging this link to target to the other link as well. Now I am applying sorting on this link. So we can also apply the sorting functionality on link data as well, the data which is coming in the link, using the partitioning and sorting techniques that are available over here. So click on this icon, go to the input tabs, go to the partitioning technique. There, I want to apply the same partitioning or entire partitioning. And then I also want to perform the sorting as well on column total marks in descending order, because the highest marks should be given with first rank, right? And here it is asking which sorting should be performed. Either is fine, either stable sort or unique sort. I'm applying stable sort, and this should be descending order. To come to this option, right click on this particular link and then click on sort direction descending. So what it is going to do is, this is going to sort the data based on total marks from the link data that is coming in this link, in the second link. Let me show you. So here, whatever data is coming in DS link 29, that data will be sorted on total marks in descending order. Okay. Now here, what I need to do, I need to do the ranking. So I'm adding a new row as rank, which should be an integer. Now what I need to do, I need to assign a rank, which is nothing but a row number. So there is a function called row number, which is going to assign 1, 2, 3, and so on. That is, let me check where it is. So this is available in system variable. Right click in the blank area and click on this system variable. So there I want row number, which is nothing but in row num. But now you are going to get a wrong data for sure, because this row number will be given per node. Say suppose my data is executing on 2 nodes, then on each node I will get 1 and 1. So rank 1 will be given for 2 rows. So I'll explain how to sort that out. Because before having understanding on this one, we also need to understand couple other system variables like partitions. So number partitions, in row num, and partition num. These three need to be understandable before applying them, so that we will get the rank in a sequence. But this in row num is going to give numbers starting from 1 to 1, 2, 3, 4, 5, 6, something like that. We will get everything. Let me try to execute this stage in a sequential mode and see what is going to give desired output. So it will be there here in the stage. In the advanced section. So I'm keeping this execution mode as sequential. Then the nodes will not come into picture. Okay. Let's see how this is going to work. I also not kept any target stage. Peak stage is used to debug your code or debug your job. So the data which is coming to this transformer can be viewed through the peak in the logs. I'll show you how the peak stage is going to work now. No need to define the output tab for peak stage. Okay. Let's execute this one. So the data will be shown here. Just now the job started. Job got finished. So here you see peak 33. So here you can see how the rank is coming. Total marks, percentage, roll number. Okay, rank is here. Rank 1, 3, 5, 7, 9. Let me copy this data and check whether it is giving correct rank or not. This is not giving correct rank because for 78.2% it is giving rank 1, which is wrong. And let's check here also. All 78.4. So as I told, the mistake is here in the rank derivation, only in row num is not going to work, but this particular system variable is going to generate numbers from starting from 1 till the number of rows. I'll let you know how this can be calculated. To know that one, we also need to understand node configuration, partitioning, and 3 system variables. Those 3 system variables are partitions, partition num, in row num, and there is another one. Partition num, number of partitions and partition num. I will explain those 3 system variables, and then here we will derive the derivation so that it can able to give the rank as expected. Okay. You can practice till calculating the percentages. Only the above section, not this section. Okay. Thank you. Bye.